the game on the screen. We'll start with the Minimax principle. Remember, for A, we have to get for each strategy the minimum gain and then the maximum of that. So that's the maximum of the minimum of the rows of A. So that means the maximum, or for each row we take the minimum, which is -3 here. This here is -2 and -2, so that's equals to -2. For B is the opposite, so here is max, here is min, and here goes the columns. So this is the minimum of the maximum of each column. First column, the maximum is 2, on the second is 3, then is 5, and 4, this is equals to 2. As -2 is not equals to 2, we have no pure strategies equilibrium. And we'll have to search a mixed strategies equilibrium. Here the game on the screen. We'll start with the Minimax principle. Remember, for A, we have to get for each strategy the minimum gain and then the maximum of that. So that's the maximum of the minimum of the rows of A. So that means the maximum, or for each row we take the minimum, which is -3 here. This here is -2 and -2, so that's equals to -2. For B is the opposite, so here is max, here is min, and here goes the columns. So this is the minimum of the maximum of each column. First column, the maximum is 2, on the second is 3, then is 5, and 4, this is equals to 2. As -2 is not equals to 2, we have no pure strategies equilibrium. And we'll have to search a mixed strategies equilibrium. Next step is to consider dominant strategies. So let's compare B1 and B3. So this will be B3. Here on the first row we have 5. This is the loss of 5 as opposed to a loss of 2. So B3 is worse. Loss of 1 as a gain of 2. So again is B3 is worse. And here loss of gain of 2 and gain of 2. They're equal. So we have B3 is greater than B1. 5 is greater than 2. 1 is greater than -2. And -2 is equals to -2. Which means that we get rid of B3. Because remember, the rules are for A, we get rid of smaller rows, and for B, we'll remove the bigger columns. So we're left with the matrix 2, -2, -2, 1, 3, 3, and -3, 3, 4. If you inspect this matrix again, you can check that we can get rid of the second row. Why? Because 2 is great. 1 second here. Okay, these are equal. This guy and this guy are equal. This guy and this guy are equal. This guy is less than this guy. So we can get rid of the second. So remember, it was A1, A2, and A3, and these were B1, B2, and B4. Has been reduced to 2, 1, -3, -2, 3, 4, with the strategies A1 and A3, and B1, B2, and B4. How do we solve this? Okay, we have to do a little bit of drawing. Our game, therefore, has been reduced to this one, where A has two possible strategies, A1 and A3. And what happens in this situation? This is like a 2 by 2, a little bit bigger matrix, that's all. But basically what happens, A will play P times this and 1 minus P. And depending on what B does, the value of the game, how much A gains, will be different. If B plays B1, we're in this row, and P is equal to 0, this is 0, then the value of the game is -2. And if P is equals to 1, then the value of the game is 2. The value of the game is 4P minus 2. you can check P0 minus 2, P1 is equals to 2. If B chooses this second option, which was B2, then if P is 0, means the upper one is not being played, only the second one, so the value is 3. If P is 1, the value is 1, and this line is given by 3 minus 2P. In the case of B4, which is this one, if P is 0, means the A1 is not played, so value is 4. P is 1, the value is minus 3, and the value of the game is here 4 minus 7P. Which option to choose? We need to do a little bit of drawing, so we have to draw these lines here. So for that I have used Geogebra, I will input next. Here are the three lines from the previous page. Here we have L1, which is the line where the value of the game is given by 4P minus 2. Then here we have L2, where the value of the game is given by 3 minus 2P. And this one here is L3 with value of the game given as 4 minus 7P. Remember, A is trying to gain as much as possible and B is trying to stop it. Remember, what we're doing for A is the maximum of the minimum. Any minimum value of gains for A is okay for B. So all these are allowed for B. B will allow this to play. But when it comes here, it will not allow to cross to this side because B will play a strategy that stops. So all the possible gains for A that B cannot prevent are up to here, and this is the maximum gain for A, which is intersection, as you can see, of L1 intersection with L3. This is the maximum gain that B is going to allow for A to get. So this is the minimum. The minimum goes up to minus infinity here, and then the maximum. And here you solve it. L1 intersection L3 means V equals 4P minus 2, and V equals 4 minus 7P. You solve for this, you get V is equals to 6 over 11. Sorry, that's P. P is equal to 6 over 11, and V is equals to 2 over 11. On the game, for the part of A, P is equal to 6 over 11. This means P will play 6 out of 11 times. We play A1, and then 5 out of 11 we play the strategy. The strategy was, let me see it here, it was A3. A3. And we have the intersection of L1 intersection with L3. So the matrix we were considering, which was 2, 1, minus 3, minus 2, 3, 4. This is L1, L2, and L3. This will disappear, and the actual matrix will be 2, minus 3, minus 2, 4. What about B? What about B?